So basically, all the friends here, hello everyone, and welcome back to our channel Schrödinger's Cat. Today we have the incredible honor of hosting Professor Navinder Singh, a renowned expert in condensed matter theory. Professor Singh has made significant contributions to advancing our understanding of this fascinating field, exploring everything from the fundamental nature of matter to its vast application in technology. In this interview, Professor Singh will share his journey in research, offer valuable insight into the challenges and rewards of a career in science, and discuss the importance of diversity, funding, and the direction for young scholars. Whether you are an aspiring researcher or simply curious about the world of condensed matter, his conversation promises to be enlightening and inspiring. So now go ahead. Basically, his field is condensed matter physics theory. He is an renowned and honorary professor and as well as the scientist in PRL Ahmedabad Physical Research Laboratory. His current and near further research interest is anomalous electronic transport in the strange metal remain of unconventional superconductors. Next, theory of unconventional superconductivity, heavy fermion and ferrous-based compound, and his renowned book for the scholars is Electronic Transport Theory from Weakly to Strongly Correlated Material. So basically, welcome, Professor, and just go ahead some
Thank you, Deva.
query. Yes, sir.
Yeah, thank you, Deva, for inviting me. So, as I understand, this platform is for young students doing BSc and MSc and who are preparing for the JUST and GATE exams, and for students who are passionate to do science, specifically physics, research in physics. So, what I would like to say to you is that from my personal perspective, uh, I myself, I did BTech in electronics and communication engineering. And later on, I switched to physics because from the very beginning, I was interested in physics. So my childhood passion was in physics and particularly astronomy. I grew up in a village and I was fascinated by night stars and I made my own telescopes and I used to see these planets and I was fascinated by these astronomy, astrophysics, basically. And then it turns out that so I did my BTech, but after the BTech, I was applying for exams and I came across about the joint entrance screening test in employment news. Then I filled this exam and then luckily I cracked this exam and I passed the interviews. So I got offer for PhD positions at various places and I selected Ramana Research Institute, Bangalore. So I was there from 2000 to 2006 in the Ramana Research Institute. And my passion is in theoretical physics, basically because I was doing engineering. So I was not aware of what kind of research is going on. So what I am thankful to Raman Research Institute. So I spent 1 year in astronomy astrophysics division. So I learned the basic of astronomy astrophysics division. Then I also was in optics division and then in theoretical physics division. I took various courses there in Tata Institute, which is also called Indian Institute of Science. And then slowly, so I came aware of this field of theoretical condensed matter physics. So my problem at the time of PhD, I was interested in the study of hot electron relaxation in metals. So that theoretical study I initiated. So there was experimental group in RRI also regarding the relaxation in nanosystems. So I was interested in both experiments and theory, but theory then I took with the help of Professor N. Kumar and Professor R. Srinivasan. So because I was just motivated, I just kept studying that topic and I could do a PhD.
Yes,
and in Raman Institute. And after Raman Institute, I went for postdoctoral positions. One in the Institute of Physics, Bhubaneswar, then Holon Institute of Technology, Israel, then University of Toronto in Canada. So after that, I got a permanent position in the Physical Research Laboratory, Ahmedabad,
Yes, sir.
and I am doing research on unconventional superconductivity, which is a part of theoretical condensed matter physics. So you know that the BCS theory can explain superconductivity in elemental superconductors like mercury.
Yes,
It can
sir.
explain lead. It can explain the strong coupling theory. But the discovery of cuprates in 1986, and then heavy fermion superconductors, then recently iron-based superconductors, nickelates,
Yes,
all
sir.
these systems obey what is called unconventional superconductivity. So I am doing research in that area.
Yes, sir. Fine, sir. So now go ahead our discussion that career path and motivation. So what initially inspired you to pursue condensed matter theory as your field of research?
Yeah, so see the condensed matter theory, because uh, my passion is that I want to do research which is close to the experiments. So in condensed matter physics, uh, you are so the condensed matter physics is well determined by experiments. So
Yes,
for
sir.
example, you want to measure the resistivity of a sample. Let us say you have some sample. So let us say this is some sample, and then this is a plastic thing. Let's say imagine that is some piece of metal. Imagine, and then you can pass current through it, and then you can measure what is the voltage drop across it. You can measure the resistivity. Then you can change the temperature. You can see how the resistivity changes with temperature. So in condensed matter physics, you have a lot of experimental information. So for example, in the case of resistivity, so the question is how, if there is a particular way the resistivity is increasing with temperature, so you
Yes,
would
sir.
like to ask the question, why the resistivity is increasing with temperature? So then you go to the macroscopics, that there are electrons, because electrons are negatively charged particles. You apply potential difference. So there's a positive terminal, there's a negative terminal. So electrons will be drifted towards the positive terminal. So when the
Yes, sir.
electrons will drift, so they will collide with the ion cores, and then they will feel a retardation. Due to this retardation, there is a Joule heating. You know that when the current is passing through a material, it heats up. There is Joule heating. Then you have to understand what are the scattering mechanisms happening inside the metal. And from the microscopic perspective, you can actually derive the expression for resistivity. You can calculate resistivity. And that calculation, if it agrees with the experimental data, then your theory is correct. So basically, in condensed matter physics, you have the way to test your theories. Immediately you can test your theories. So that way you can work very close to nature. And in doing so, you learn a lot of insights, a lot of new ideas about nature. Okay. And this is, you can say, it's quantum mechanics applied to matters. Okay.
Yes, sir.
In bulk matter. So that is why particularly I'm fascinated by experimental phenomena, and I love to devise theoretical explanations. I want to understand things. So that's my passion for condensed matter physics.
Yes, sir. Now our next query for the field area and research focus, that what are some of the current and most exciting topics in condensed matter theory?
Yeah, in the condensed matter theory, the problem is the high temperature superconductivity problem is old problem. I agree, the 30, 35 years old problem, but this is still an open problem. This is still an open problem. It's very difficult problem, very challenging problem. Lot of Nobel laureates has worked into this field. The Nobel Prize is given for the discovery of high temperature superconductivity, experimental discovery, to Bednorz and Muller in 1987. The experimental Nobel Prize is given, already given. The theory Nobel Prize is not given because there is no theory. So definitely it's a Nobel Prize winning investigations. If you are able to successfully solve this problem, definitely you will get a Nobel Prize. Okay, but that's not, one should be motivated for prizes. It's not that one should do research to for medals, getting medals or getting recognition. It's not the way you should do research. The only thing is that in this is that this is a challenging problem, and this is a very hard problem, and it has practical applications, because once you discover the mechanism of high temperature superconductivity, then you have the ways to develop materials which will be superconducting at room temperature. Look at the technological applications it will bring. Definitely it will bring you will have, there is going to be a revolution in technology. So the wires which carry power from one town to one city to another city, 20% of the power is wasted. 20% of the power is wasted. So if they are superconducting at room temperature, so how much power you will save? And your technology will change. You will have your NMR machines, your medical science, it will have applications. It will have nanoscience applications in nanoscience also. It will have a lot of applications. And the thing is that why this problem has been not solved, almost 35 years has gone, and not just one, many Nobel laureates has worked in this problem. So it's really hard problem. It's
Yes,
really,
sir.
really challenging problem. So if you are fascinated by challenging problems, like I am fascinated by challenging problems, some problem which challenge your intuition, that is where I want to put my energy, because that challenge me. So that is why I want to understand this problem. Maybe I may not be able to successfully solve this problem, but I will be able to make some progress. I have done some research in this. I have published some papers. I am getting progress, like other people is getting progress. But the question is whether I am able to solve the problem or not is a separate issue. It depends upon so many factors. The problem is definitely difficult, definitely very difficult problem. Another set of problem is related to superconductivity in heavy fermion material. That's also old but challenging problem. Then there are comparatively recent problems which are more sort of related to topological aspects of condensed matter physics. Topology, like fractional quantum Hall effect. From there, this topological insulators concept emerged. So then you have topological superconductors, topological insulators. There are new materials people are synthesizing which have topological properties. And those things, people are finding applications in decoherence. More specifically, you can have quantum systems, because there is another parallel where people are trying to make quantum computer, because quantum
Yes, sir.
computer is again a Nobel Prize winning thing. Whosoever is going to make a major development in this field is something is going to change the world. So there also these kind of materials are useful. So the topological condensed matter physics is another frontier, which is highly useful in the current scenario. So then there are nanosystems, graphene, nanotubes, those materials are there. Then more recently,
Yes,
the
sir.
bilayer graphene is one hot topic, bilayer graphene. Then there are van der Waals materials. There are many branches of condensed matter physics. It's a very vast field. And so you should actually explore this field and try to read, listen to talks of experts, and then you should work in an area which is close to your heart. I'm not saying that you should work in condensed matter physics. Actually, you have to decide yourself. You have to look into yourself. What is the passion? So are you interested in astronomy, astrophysics, or you are interested in optics? Like you may be intrigued by photonics, optics, for example. Yeah, so the light has these colors, wave nature of light, particle nature of light, and you'll be motivated by what is the stuff made of. Like you have protons, neutrons, atom,
Yes,
then
sir.
the electrons all around this thing. The protons are made of quarks. Then you can ask the question, what are these quarks? So what are the fundamental degrees of freedom? So that can also be a motivation, and that leads to particle physics. So the point is that you look into yourself. You don't pay attention to whether the field has a lot of applications. Uh, it will be useful to society. That is one aspect, but that's not the reason that you should choose the field. The point is that you have to explore yourself, and something which is close to your heart, you should follow that. Okay,
Yes, sir.
even if it may be fluid mechanics, it may be aerodynamics. It's okay. You should go for that.
So go ahead. Our next query for the topic is diversity in research. So, in your opinion, how diverse is the field of condensed matter theory in terms of research approach and many perspective?
Yeah, as I told you that this is very diverse field. Condensed matter
Yes, sir.
physics is very diverse. So it has so many subfields. Even the statistical mechanics is field. So in statistical mechanics, you know that last century, in the 20th century, or okay, maybe in the 19th century, people were interested in thermodynamics, and it was a hot topic. Then the 20th century, so in the 19th century, people like Ludwig Boltzmann, Maxwell, and all. So they developed statistical concepts, and statistical mechanics was a hot topic. Okay, so the thing is that fields come and then people do research in the fields, they settle down, the fields will settle. Now statistical mechanics is a core course in your MSc. So but still there are topics in statistical mechanics which are still under investigation. So one of the topic is, how do you apply statistical mechanics to communities? For example, there are communities, okay, in social setting, how statistical mechanics of social settings, or statistical mechanics of traffic,
Yes,
and then the application of statistical mechanics to biological systems. That's a hot topic. Definitely after 100, 200 years in future, so this branch will be a settled branch. It will be a topic in your MSc or BSc. So that is how science develops. So currently, statistical mechanics of biological systems is a very interesting topic. For example, inside the cell, there are so many mechanisms, chemical reactions are going on. Cell it burns energy, it produces, it multiplies, right? It's like a small machine. It takes food, energy from the food, and then the blood comes, and some ions are filtered in, some ions are not filtered in. Okay, so it's a dynamical system. So the question is, how do you understand this dynamical system from physics point of view? Like, what are the laws which are followed by a living organism, like a cell, like a bacteria, for example? So you have to advance thermodynamics, because this is the thermodynamics that you study. Okay, that is applicable to heat engines, but the thermodynamics which will be applicable to cells, for example, at such
yes,
a
sir.
small scale, that thermodynamics is different thermodynamics. So people are trying to develop statistical stochastic thermodynamics. So that's the area of research also. It's also part of condensed matter. So what I would like to say is that the condensed matter is extremely, extremely vast.
Yes, sir.
So there are biological systems, then there are complex systems, then there are material science, then there are superconducting materials, then there are magnetism, for example. Very interesting magnetic materials are available. A lot of research is going on in magnetic materials, because magnetic materials have a lot of applications also. For example, in recording memories. So when you magnetize the material, so the spins will align in particular direction, so you can store a memory kind of
Yes, sir.
thing.
So now
So
go ahead for the other topic, that research opportunity and direction. So what advice would you give to students about choosing a specific research direction within this field?
so this is one thing. You should be passionate about doing research. You
Yes, sir.
so you should have love for science. That is number one. Now number or gate or net. है ना? Now you see there are a lot of competition going on, right?
Yes,
And
sir.
what I would like to tell to you from my personal, because I have not done BSc, I have not done MSc, but I still cracked the just exam, because I studied two books. One is the reciprocity physics. I, it was gifted to me by my father when I was in +1. So for 2 years, I studied this book. I solved, and even after 4 years of a BTech, all the training was there in my mind. And then I also studied 5 main lectures, 3 IE Erudo, and electrodynamics by Erudo,
Yes, sir.
classical mechanics by Erudo. So basically the point is that you solve a lot of problems, numericals, hard problems. First you solve simple problems. There are a lot of problem books available. So you should solve those problems. Once you have skill to solve problems, and then you should have good mathematical skills also. For mathematics, I would like to suggest to you, there are so many books. One is Rafkin Weber. So the thing is that you should solve, you should not study physics and mathematics. You should do mathematics and physics. It has to be done with paper and pencil. Okay, that's it. There is no need to mug up things and know too many things. Only skill required is solving problems. Because once you solve problems, you acquire skill to understand these things. And in just exam, net exam, it's all problems, right? Okay. And also the thing is that if you have passion, the thing is that if you have some interest in physics, then automatically you will learn physics because you will be
Yes, sir.
absorbed by it, right? If you are a passion for chemistry, but you're studying physics, then you will not learn physics, even though you're
Yes, yes,
spending 8 hours or 10 hours on physics, because your heart is in chemistry. But if you are sort of passionate about chemistry, whatever you will read about chemistry, it will go to your long-term memory. It will go into you, right?
yes,
So first of all, you should be passionate. I'm not saying that you should be passionate about only physics, whatever it is. It may be even sports. I am not even you. Somebody may not be like study at all, but the fellow may be like running. So I would suggest that get up early in the morning at 4 a.m. Go for 2 hours, just do the practice running. You run for 100 meter, 200 meter, again and again. You will become a champion. Okay. So first, find your passion, number one, and then you devote yourself to fulfill your goal. And the only way is hard work. You practice again and again, again and again, hours and hours you practice. That also, if you are interested in mathematics, do all books on mathematics. Start early in the morning or late. You should study more than 12 hours a day. I mean, you should forget everything. That should be your focus. Mathematics means mathematics. You keep studying mathematics. You will crack exams. You will become a mathematician. Everything. The jobs automatically will come. Once you excel in, if you are if you are at the top level, everybody will hire you, no matter which field. Whether it
yes,
is
sir.
mathematics, or it is physics, or it is chemistry, okay, or sports, right, or
Should be some
sociology.
arts subject like English or
Even if you love arts, you read, you work hard in arts, you will write poetry, but you become cutting edge.
yes,
And cutting edge means your passion should be there. Your passion and your hard work must align. Okay, so don't follow social pressure or stigma. Oh, there is no job in this field. Every field has a job. Only thing is that you should be at the top.
yes, sir.
Okay, yeah.
So now go ahead our next query, that funding and resources. So what are the biggest challenges you have encountered regarding research funding?
See, research funding, you will face a lot of trouble if you're in a university, because universities, the funding is very difficult. Now maybe the situation may improve in the coming years. So my experience is that I'm in a research institute like PRL. So
Yes,
funding
sir.
is not the issue. So
Yes, sir.
research institutions, if you want to do experimental science, you go to a research institute like Tata Institute of Fundamentals at TFR, IIC Bangalore, PRL like Ahmedabad, right? Ramani Research
Yes, sir.
Institute, right? Or Bose Institute in Kolkata, or ISER Kolkata. There are a lot of institutions in Kolkata, like Saha Institute is there. So in institutes, funding is not that problematic. I mean, you should have a good idea. And also, it's not always theory. And some people will passionate about doing experiments. It's okay. You may be not liking too much theoretical stuff. You maybe love to do experiments. Professor C.V. Raman, he was experimentalist. He loved to do experiments. So you can become an experimental physicist. And that also is a great career. You can discover new things. He discovered Raman effect. Experiments need money. Doing
Yes,
modern
sir.
experiments need money. And so it is better that you square a position in some research institution. You should be in a cutting edge research institutions where the money is there, because equipment is very costly. Theory, okay. Theory needs paper and pencil and books. So there you not need much money.
Yes, sir.
Yeah.
So everyone should go to the research institute for their PhD. This is our
Not
this is
everyone. Okay. Yeah. I mean, like, there are not only research institutions, but there is a ISER, NICER, IITs also doing very good. So there are a lot of opportunities, right? There are a lot of opportunities. I mean, you have to explore basically, and also the basic thing is that you prepare well for your exams. First thing first, you prepare well in your exams, and then depending upon your interest, you should not compromise with your interest.
sir, yes.
And if you are not certain what is your interest, explore. Go to inside. I will go to various departments. I will learn what people are doing. Give me 1 year. Then I will decide later on. You can have this sort of understanding. Decide later on. You can with the institution. You explore. You study, and then after 1 year, why to rush? You should explore, and then you okay.
So now go ahead in other challenges in research. So what are some of the most challenging aspect of research in condensed matter theory?
Yeah, I think this is the last question. We have to wind it up. So challenges, actually, I already told you. Challenges is basically depend. Not
Yes, sir.
that importance is different. So sometimes easy problem can be important. Like, okay, what is easy, what is hard is also sort of subjective. Okay, so so the challenge is like the problems which are difficult problems. One example is the high temperature superconductivity. It has its own difficulties. There are many parameters in it, and there are conceptual difficulties also, as well as mathematical difficulties. So so the point is that you should actually try to attack real problems, which are closely tied to the experiments, because you can have theoretical problems, academic interest, where like hypothetical problems, which may not be directly relevant to real systems. So those problems I think should be avoided, because just for example we can generalize to higher dimensions and mathematics. Then it part of mathematics, it is interesting problem, but more in condensed matter physics, the thing is that you should be close to experiments.
Yes, sir.
That would be nice.
Yes, sir.
Okay.
Last but not the least, that the advice for the student and the scholars for your aspect.
So my advice is that first solve a lot of problems. Start with Resnick Halliday physics. Okay. Then there are Irodov books, and then there is a Feynman lectures. Then there are your basic quantum mechanics. For example, quantum mechanics, J.J. Sakurai is a good book. Statistical mechanics, Ladau-Lifshitz books are there, and you study well and make your notes, solve a lot of problems. Then there are 3 volumes of Landau-Lifshitz, shorter course. There are 9 volumes, big course, there's shorter course. So the books is very central. So you should study from foreign authors. Okay, it doesn't mean that there are good Indian books also by Indian authors. I'm not saying that, but you should study from
Yes,
books
sir.
which has been time tested.
Yes, sir.
Time tested.
Yes,
So
sir. Yes.
not only solve problems, basically solve a lot of problems. It will
Yes,
be
sir.
automatic then. Solve a lot of problems. More how you work hard. You work hard at home, then you will be very good in the interviews.
Yes,
Or
sir.
in
Yes.
research, it will flow. Yeah.
Yes, sir. So finally, sir, just conclude and remark of our conversation according to your own word in this conversation. Just conclude and the remark.
Yeah. Thank you very much for this interview. It was nice interacting with you. And so the thing is that my advice is the same actually, and the people should follow their passion. And it's not that you would lack passion. People just have to sit peacefully, and it's not easy for everybody. Some students are from very weak financial background, so there will be a lot of issues at home. Family background is there, so there are a lot of problems. Sometimes you will face financial problems, but don't be discouraged by that. Sometimes there is a family requirement that you should do some job. No problem, you can do job. Like for example, Einstein, he did job because he needed money, but during job time, he was doing job, but in the evening when he was free, he was doing science.
Yes, sir.
So it is not that your journey will be stopped if you do some job in industry. If you have a passion, then even then late night you can study. Finally, you can move to the institutions. I
Yes, sir.
mean,
Yes, sir.
you follow your passion actually. Don't be bothered by it, and the passion may be even in photography,
Yes,
wildlife
sir.
photography. Just follow
Yes,
it
sir.
up. Don't be discouraged. So you can earn some money to for the livelihood that everybody has to sustain oneself at one point of time. You cannot be always dependent on parents. So you have to earn your money. But once you make sure that you have made money for your living, then you should follow the passion. And then also now there are so many opportunities that you can follow your passion and earn money,
Yes, sir.
right? You want to become a physicist, then even in a university you can teach, you can become a professor, you will get good salary also, but you can also do research of your choice. Hmm?
Yes, sir.
That is good. Hmm?
Yes, sir. So
Okay.
finally, sir, so finally, I conclude just my word that thank you very much, sir, for you for
Yeah, welcome.
attending this interview for the benefit of the students and the scholars,
Thank you, Deba.
spending
Thank
your
you.
more valuable research time schedule. Thank you very much, sir. Goodbye. Thank you, sir.
Yeah, welcome.
Yes, sir. Thank you,
Thank
sir.
you. See you. Bye bye.
Thank you, sir.
Yeah, bye.
Yes, sir. Thank you. Goodbye, sir. Thank you.